Multiplication of vector by scalar. In this lecture, we will discuss what happens when a scalar is multiplied with a vector. Scalars could be of two types: dimensionless scalars and scalars which have dimensions. So there could be four possible cases of multiplication of a scalar with vector, and we are going to discuss all the four cases. The first case is when a vector is multiplied by a positive dimensionless scalar k. So here k is a dimensionless quantity. So this is the vector A, and I want to find out what will happen to this vector when it is multiplied by a positive dimensionless quantity. Simply, its magnitude will increase k times. The direction does not changes. The dimension does not changes. Why? Because k is itself dimensionless, and the magnitude becomes k times of its initial magnitude. The second case will be when a vector is multiplied by a negative dimensionless scalar minus k. So this is the vector A. It has to be multiplied by a negative dimensionless constant minus k. The result will be the vector will reverse and the magnitude will increase k times. Therefore, in this case, the direction reverses. Why? Because minus k is a negative value. The dimension does not changes because k is dimensionless, and the magnitude again changes by k times. Thus, a vector minus a vector can be said to be equal to product of -1 and a vector. The third case will be when a vector is multiplied by a positive scalar with dimension. For example, force is equal to mass into acceleration. Momentum is equal to mass into velocity. Here, both force and acceleration are vector quantities. Similarly, momentum and velocity are vector quantities. Mass, which is a scalar quantity, is multiplied by a vector quantity acceleration. The resulting quantity is force, which is also a vector. So when a scalar quantity is multiplied with a vector quantity, it remains as a vector. The direction of force will be same as direction of acceleration. Similarly, when mass is multiplied by velocity, we get momentum. Momentum is a vector quantity. Mass is scalar and the velocity is vector. The resulting mass into velocity will itself be a vector whose direction will be same as the direction of velocity. So whenever a positive scalar is multiplied with a vector quantity, the direction does not changes. For example, this is the acceleration vector. When we multiply it by mass, m into a will be a new vector which will be in same direction as the direction of acceleration. Thus, the direction does not changes, but the dimension changes. The dimension of acceleration will not be same as dimension of mass into acceleration. The dimension of mass into acceleration is same as dimension of force. So when we multiply a vector quantity by a quantity which has its own dimension, the resulting quantity after multiplication will be altogether new quantity. For example, after multiplying mass with acceleration, we get a quantity which is force. We cannot compare the magnitude of force and acceleration as they are different quantities. The numerical value of force will be m times the numerical value of acceleration. It simply means we cannot compare in terms of magnitude that which of the two quantities is bigger, simply because they are altogether different physical quantities which cannot be compared with each other. And the last case is when a vector is multiplied by negative scalar with dimension. For example, let us say a vector is equal to minus k into b vector. In this case, b vector is multiplied by a negative scalar quantity minus k. The result will be a new vector quantity A. The direction will reverse. A will be anti-parallel to B. If K has its own dimension, the dimension of A will be different from the dimension of B. Thus the dimension changes. Further, we cannot compare the magnitude of A with the magnitude of B because they will be different physical quantities. Note that the results we have discussed for multiplication of vectors with scalars will also be true for division of vectors by scalars. This is because any division can be written in form of multiplication. For example, a vector divided by k can be written as 1 by k into a vector. Thus a vector divided by k is nothing but multiplication of 1 by k with a vector, where 1 by k is a new scalar. So all the cases we have discussed above for the case of multiplication will also be true for the case of division of vectors by scalar.